Come DIKWP, Shogun aboard. Your learning journey starts now. Alright, let's dive right in. We're talking about innovation, that magical spark that changes everything. But what really makes it happen? Is it just random genius, or is there a secret sauce? Today, we're cracking open a new model that might just be it. DIKWP Triz. Get ready for a quick, fun ride through the future of innovation. So, first up, meet the dynamic duo, DIKWP and TRIZ. Think of DIKWP as your brain's GPS for understanding. It's not just data, information, knowledge, wisdom like the old DIKW framework. No. Professor Yu Kongduan added the ultimate boss level, purpose. It's like asking not just what, but why. Why are we doing this? This gives us a global semantic chain, turning raw data into wisdom with a clear goal in mind. Perfect for AI that actually understands human values, not just crunches numbers. Then there's TRIZ, the theory of inventive problem solving. Developed by Soviet inventor Altshuler, it's like a cheat code for innovation. He looked at thousands of patents and found 40 universal inventive principles. The core idea? Contradictions. Like, how do you improve performance without reducing safety? TRIZ gives you systematic tools to solve these head-scratchers. It turned invention from an art into a science. But classic TRIZ had its limits. Complex, technical, and sometimes missed the big picture of purpose and ethics. So, what happens when you fuse these two powerhouses? You get DIKWP TRIZ. It's like giving TRIZ a soul, making innovation both technically brilliant and value-driven. We map TRIZ principles to each DIKWP level, creating a super-powered innovation toolkit. And get this, they even built a DIKWP times DIKWP matrix, a 5x5 grid, to make sure we're using the right tools at the right time, avoiding redundancy. It's like having a cheat sheet for the cheat codes. Okay, buckle up, because now we're getting conceptual. Imagine innovation isn't just a step, but a leap. Not a small hop, but a giant jump across multiple dimensions. We call this a tensorial leap. Think of it as happening in a DIKWP times DIKWP space, basically, two DIKWP frameworks interacting. One represents the problem, the other, the solution. Where they collide and interact, that's where magic happens. This isn't just about improving one thing, it's about changing everything simultaneously. It's a jump across data, information, knowledge, wisdom, and purpose all at once. For example, maybe you reinterpret some data D to create new info I, while simultaneously breaking an old knowledge paradigm K to form a wise insight W, and finally, introduce a brand new purpose P. That's a tensorial leap. It's not just moving up the ladder, it's rewiring the whole structure. And this leap has two key parts: semantic transformation, reorganizing meaning, connecting dots nobody saw before, and value ascension. Every good innovation elevates the value, leaping higher in the DIKWP hierarchy. From data to wisdom, from wisdom to purpose, that's the value climb. It's like Einstein's paradigm shift, but mapped out mathematically. Now, how do we actually measure and understand these leaps? Enter semantic mathematics. This isn't your grandpa's math, it's math that gets meaning. Every symbol is tied to real-world semantics. It helps us quantify the fuzzy stuff of innovation. First tool, the semantic matrix. Think of it as a map of your ideas. It shows concepts and how they connect. For knowledge, it's like a knowledge graph's adjacency matrix. Nodes are concepts, relationships are links. We can even use matrix math to simulate how semantic networks grow and combine. Want to find connections between different fields? Tensor products of their matrices can show potential cross-domain leaps. Cool, right? Second, cognitive distance. How far apart are two ideas? This measures the gap in semantic space. Big distance? High novelty, but also high risk. Small distance? Incremental improvement. Think GPT-4. It handles large cognitive distances, synthesizing diverse data across levels. Bridging this gap is often where true innovation lies. We can even calculate it using vector math or graph paths. It tells us how challenging and potentially valuable an idea is. Third, logical leap. This is the aha moment, the epiphany. It's not step-by-step logic, it's a sudden jump to a new hypothesis. Semantic math helps formalize this. Maybe by adding a new node to our semantic matrix, bridging a contradiction. It's like escaping a local minimum to find a global solution. Many TRIZ principles, like change perspective or dimension change, embody this leap. Mathematically, it's like adding new dimensions or constraints to break free. So, we have these powerful tools, but where does the actual problem solving happen? It starts with contradictions. Remember TRIZ? It's all about finding and resolving conflicts. In the DIKWP world, these are semantic contradictions. Maybe it's a clash within the same level, like two conflicting knowledge claims. Or it could be a cross-level fight, like your purpose level wanting safety, but your technical level pushing for speed. Classic examples: accuracy versus privacy, or efficiency versus safety in autonomous driving. The beauty of DIKWP is it helps pinpoint exactly where the contradiction lives. Is it at the data level, knowledge level, purpose level? Once identified, we pull out our TRIZ toolkit. Need to separate conflicting requirements? Use contextual separation. Can't satisfy both? Maybe a hierarchical trade-off at a higher level. Add redundancy? Introduce an intermediary concept? Or find functional aggregation that hits multiple goals? DIKWP TRIZ even suggests a hierarchical resolution method. Start with the purpose level, setting the value descent, then work down through wisdom, knowledge, and information, ensuring every step aligns with the ultimate goal. It's like building a solution from the top down, ensuring nothing goes off track. This makes innovations, especially in AI, more transparent and trustworthy. People can understand why the AI made a certain decision. So, what's next? This isn't just theory, it's a game changer for how we manage and share knowledge. Enter DIKWP assetization. Imagine treating knowledge itself, data, information, insights, even intentions, as digital assets. Each piece, from raw data to high-level wisdom, becomes a structured unit with clear ownership and traceability, thanks to semantic blockchain. We can even tokenize them as NFTs. Your brilliant idea? It's a tradable, verifiable asset. Pricing? Based on value ascension, wisdom is worth more than data. And because it's on-chain, contributions are tracked, incentivizing real innovation and collaboration. Forget silos. We're talking about platforms like DIKWPAS, Platform as a Semantic Service. It modularizes the entire DIKWP process into cloud services. Data, analysis, knowledge graphs, decision support, even purpose management, all plug and play. Trust comes from the blockchain, not just between partners, but in the system itself. Sharing becomes controlled, licensed, and fair. Everyone benefits from co-created knowledge, and value is shared transparently. It's a new model for collaborative innovation, where 1 + 1 is greater than 2, driven by trust and semantic clarity. The future of innovation is looking pretty bright, and it's explainable, ethical, and collaborative. Thanks for joining me on this whirlwind tour.